So now we're going to start to look at, right now it just seems like I have this I, and it's just basically a placeholder for the square root of -1. But some interesting things can start to happen. So here I have a problem that says, which of the following is equivalent to 5i times 6i? So if I multiply these two together, I is a number, but it also kind of acts like a variable. So just like x times x is x squared, I times I is I squared. Now, if this was just 30x squared, I would be done. But we want to think about, since I is a number, what does I squared mean? And I squared, if I is the square root of -1, means the square root of -1 times itself. And we know if we multiply a radical by itself, like radical 3 times radical 3, that's square root of 9, which gives me 3. So a radical times itself is that number. So the square root of -1 times the square root of -1 is -1. So this shows me that I squared actually equals -1. So here we have an imaginary number that went away and became a real number again. So I get -30 here, and that is my answer. And we're going to start to look at, well, what happens if I do I cubed or I to the 4th or I to the 5th? Do we have some sort of answers happening? Is there some sort of pattern in this? So I'm going to scroll down just so we can kind of see all the different powers and start to look for those patterns. So first off, I to the 0, and this is true if you take a calculator, anything to the 0 power, 100 to the 0, 1 to the 0, -500 to the 0, no matter what you type in, if you raise it to the 0 power, it always equals 1. So I to the 0 is also 1. I to the 1st is just I. Anything to the 1st power is that number. Okay, so those two are, you don't have to write anything, they're just kind of the way they work. I squared, right, we have two i's, so we have two square roots of -1. And we saw that when we have two of them, right, a square root times itself gives you that number that's in the radical, so this just equals -1. So far we have 1i and -1. Now when we have I cubed, we have 3 square roots of -1 in a row, because that's our definition of I. We know that 2 of them bunch together to make a -1. And one of them by itself, the square root of -1, is just I. So if I take -1 and multiply it by I get -1i or -I. Okay? So I actually suggest pausing the video. Basically, you're going to make groupings of 2 to get -1s. If you have a single one by itself at the end, that gives you an I. See if you can figure out what I to the 4th through I to the 7th are. So pause the video, then you can come back. So I to the 4th is 4 of these -1s, square root of -1s in a row. So this is a -1. This is also a -1, and -1 times -1 is +1. And there are other ways to do this that are a little faster, where you can think about like adding exponents and building off each other, but for now, we're just doing these nice strings of square roots of -1. So here I have a -1, another -1, and an I. So -1 times -1 is 1. 1 times I is I. So looking forward, I'm just going to write both of these down at the same time. So hopefully you have these already on your page. And hopefully you start to kind of see some sort of pattern emerging. I have a -1, a -1, and a -1 here. So -1 times -1 is 1, times -1 again is -1. Lastly, we have those same 3 -1s we just had, which we know gives us -1 times an extra I gives me -I. So if we look at this pattern, we have I to the 0 is 1, I to the first is I squared is negative 1, I cubed is negative I. 1I, negative 1, negative I. And then we go again, 1I, negative 1, negative I. And that pattern will continue over and over again because we're just adding these extra square roots of negative 1. So if you can find the spot in the pattern and you know the basic 4, you can figure out any power of I quickly, and we'll see how to do that on the next page. So these are the 4 you need to know. Anything to the 0 power is 1. Anything to the first is itself. I squared, 2 square roots of negative 1 is a negative 1. And then if you know that there's like these 4 options, the only thing left for I cubed is negative I. So these are your basic powers of I that everything will simplify down to. As we look at the next page, we'll start to see how to apply this. So looking at my first one, I'm going to write this on the side just so we have it. Okay, so we have I to the 38th. So what we can do is, first off, we'll think about the fact that there's 4 possible values here. So anytime that I'm going through something, I'm dividing, right? Like how many times, when I get to 30, how many times have I gone past the number 4? Like how many 4s do I have? We would divide to see how many times it goes into it. So I'm going to do old school division, 38 divided by 4. 4 goes into 38 9 times. 4 times 9 is 36. I write it down here and I subtract, and I have 2 left. So what this means is when I'm at 38, I've gone through this pattern 9 times. Okay, so just continue through that pattern. And then when I came back around after my 9th time, I made it down to I squared. So basically, if this remainder is 2, it tells me that I'm on I squared at this point. So that remainder, what's left when I divide, is equal to that exponent. So this is the type of work you'll want to show. So I squared is negative 1. Okay, and that's so basically find which stop you're on using the remainder and then write down what the value is. So here's 21 divided by 4, and a question is it always divided by 4? And yes, the answer is it's always divided by 4 because there are 4 stops in the powers of I. So 4 goes into 21 5 times, and I had 1 left over, which means I went through the pattern 5 times and I ended up at I to the first. And I to the first is I. So the gist here is you never would be done if you have an exponent on an I because it always simplifies to something without an exponent, one of those 4 values. So we'll do 2 more together. 83 divided by 4, that goes in, 4 goes into the 8 twice. When we subtract, I just have 3 left. 4 goes into 3 0 times. So my remainder here is 3, and I can write it here as a remainder, but really I'm just looking down at this number. So I to the 83rd equals I cubed, which equals negative I. Okay, now I'm going to talk through the next one. I know that 40 is a multiple of 4, so I know my remainder is going to be 0. So I could just write that this is, sorry, it's a little messed up when I wrote it, that this is I to the 0, which is 1. But if I want to go through that process and always show the division, 4 goes into 4 once, goes into 0 0 times, and my remainder is 0. So I'm on I to the 0, which is 1. So if you can do this division in your head, that's fine. The big work that you need to show are these steps. Some of you will always need to do the division, that's also fine. So why don't you try the next 4, pause the video, and then come back to check. So here is 51. 51 divided by 4. 4 goes into 11 twice. So this is a remainder 3. So I to the 51th is the same as I to the 3rd, which is I to the 51st. Sorry, I said that wrong. Which is negative I. So I know that because I know 48 is a multiple of 4, so I know that 51 is 3 bigger than that. So if you wanted to skip the division step, you could. I to the 30th, 30 divided by 4 as a remainder of 2. So this is I squared, which is, looking at my chart, negative 1. And you want to memorize those 4 powers of I, but also realize that you can look them up now as you're starting to learn them. 25 divided by 4 goes in 6 times. So I have 1 left over, so this is equal to I to the 1st, and I. And if we were in class, I know sometimes people will think, oh, the answer is 1. The answer is not 1. 1 is the exponent that goes on that. So remember, the remainder is the exponent, and then you just have to look up what the power of I is. 36 divided by 4 goes in 9 times with a remainder of 0. So this equals I to the 0, which is